Hey guys, today's lesson is 1.10 literal equations. Make sure you have this set up at the top of your notebook along with today's date, September 6, 2016. If you remember from your do now this morning, you talked about the fact that part A and part B, although they look very different, have the same steps to solve. A literal equation is one that literally just has variables instead of numbers. Looking carefully at part A, you made those steps based on those inverse operations that we talked about in lesson 1.6, and you follow those same steps to help you in part B. When you looked at question 3 on the do now, you should have noticed that the parallelogram formula that was rewritten is the same exact formula that you had for the parallelogram on the formula sheet. The only difference is that the focus at the beginning was on the area, whereas at the end we transferred the formula to be focused on the base. Let's look at example 1. Make sure you have this copied down on your paper. Solve for m. If mx plus g equals y. I'm going to give you just a minute to copy this down. Remember, solve for m if mx plus g equals y. I'm going to rewrite this formula so it's easier to see. I'm also going to go ahead and annotate which variable I'm trying to solve for. So in this case, I'm solving for m. So I'm going to make sure that I do something on my paper to show myself that this is the variable that I'm trying to get by itself. If we remember those inverse operations, the easiest ones to do are the ones that require addition and subtraction unless the whole thing is being multiplied or divided. So our first move here, as you probably can see, is to move this g variable. Right now it's being added, so I'm going to subtract it to both sides. I'm going to build that wall, so remember if I do it to one side, I have to do it to the other. Now, when the problem with these literal equations is that you don't have numbers that you can combine, so it's really difficult to see like the combining of like terms that we've talked about in the past. But all that happens is you're just writing the things out that just the way that you see them. So my g's are going to cancel. My mx is staying the same on the left side of the equation. My equal sign gets brought down. And then I'm just going to change this right-hand side here to y minus g and leave it the way that I see it. Now remember, we're trying to isolate this m. If we think about what's happening here between the m and the x, you should be like recalling the fact that when you have two variables or a number and a variable that are side by side without an operation in the middle, it's the same thing as having multiplication. So I want to undo this multiplication happening here between the m and the x by dividing both sides by x. I'm trying to get that m all by itself. So if I multiply this side by x, it eliminates. It's no longer there. I'm simply left with m equals, and then I'm just going to rewrite the side as I see it, y over g over x. I'm sorry, I think I said y over g. That should be y minus g over x. M equals y minus g over x. And this is simply my answer. Take a moment and look at question 2. In this case, we're asking to solve for a. Our equation says 5a minus b equals u. One more time, we're solving for a. My equation is 5a minus b equals u. Think about those allowable moves. What do you think we need to do to get this a variable by itself? You should have seen that this subtraction piece that's happening right here with the b is that easiest move to make. So instead of subtracting, we're going to add the b to both sides. I'm going to build that wall so remember that you have to do it to both sides of the equation. When you add b to a negative b, they cancel out. And I'm left with 5a equals, and then as I said before, this piece here, the u plus b, you cannot combine. So you're just going to write it out, u plus b. Remember, we're trying to get this a by itself. The operation that's happening between a number and a variable without any symbol, as you know, is multiplication. So to undo that, we're going to divide by the 5 to get the a all by itself here. And if we divide on one side, we have to divide on the other. So my 5's are going to cancel. And I'm left with a equals u plus b all over 5. And this is my final answer. A equals u plus b all over 5. Let's move on to example 3. Now this problem looks a little long. You do not have to write word for word here. Just pull out the important information. I'll be rewriting it to the side as well, so just keep that in mind. Example 3. When calculating the circumference of a circle, the formula is c equals 2 pi r. This means circumference equals 2 times pi times radius. Taira wants to rewrite this formula so that the radius, or the r variable, I'm going to make that notation here, r, is isolated. How could Taira rewrite this formula? So what I'm going to do to the side here, and this is what you should have in your notebook, is write solve for r. And then I'm going to write the formula for circumference down. So c equals 2 pi r. As we can see here, we're trying to solve for r. So I'm going to make that notation there so I just remember this is the variable I'm trying to get all by itself. So this one looks more challenging than the last ones because you have multiple numbers or variables that are all pushed together without any symbols. This works the same way as it did in the last problem when you just had the 5a next to each other or when you had the mx next to each other in example 1. What operation is happening when you see multiple variables or numbers side by side without operation there? You know it, you're multiplying. So what am I going to do to get this r by itself if it's being multiplied by the 2 and the pi? You're right, we're just going to divide it. So I'm going to divide this side by 2 pi, and I'm going to divide this side by 2 pi. You really don't have to do anything fancy here. You don't have to do any of the heavy lifting when it comes to these literal equations. You're just trying to get things moved around, so we're focusing on a different part of the equation here. So I'm going to eliminate my 2 pi's, and I'm simply left with c over 2 pi equals r, which is my final answer. Now, this is really useful when you get into, especially in geometry, when you do a lot of things with formulas. You won't see them as much in Algebra 1, but sometimes in geometry, you're given an equation like this, but you're asked to find the radius. So if you're able to manipulate the literal equation just like we did here, then all you have to do is just plug in your circumference and divide it by your 2 pi in order to find your radius, instead of having to do any of those inverse operations and manipulations that we've had to do in the past to solve for a certain variable. So we're going to go ahead and move on to our last example, example 4. And this time we have an inequality. We're being asked to solve for b. So we have 2/3 b plus g is greater than w. And this one's a bit of a challenge, but I know that you guys are like super rock stars and doing a great job today. So we're going to be up for this challenge. So 2/3 B plus G is greater than W. Now, as we talked in lesson 1.06, an inequality and an equation are solved the exact same way. The only difference is that you keep your inequality symbol. So the first move that we want to make is one that's going to allow us to eliminate this B, or sorry, not eliminate, to get the B by itself. So the easiest move here is to get rid of this plus G that we see right here. In order to move this to the other side, you're going to do the inverse operation. So we're going to subtract both sides by G. Go ahead and write down what you think that next line is going to look like. You should have seen that your G's eliminate, and that's going to leave you with 2/3 B is greater than W minus G. Remember, these two terms are not alike. Because they're not alike, you cannot combine them. So you're just going to write it out like we did below. So now we have to think about what's happening right here with this 2/3 B. When you see a fraction, it's like saying that you're multiplying whatever that number is by your numerator, or the 2 here, and then dividing that by your denominator, or a 3. So if this is happening, all you have to do is like flip it in upside down or find the reciprocal of the fraction to undo that fraction. So what I mean here is, for example, if I had the fraction 1/2 and I multiplied it by 2/1, so the reciprocal, if you notice I moved this denominator to the numerator and the numerator from my previous fraction to the denominator. When you multiply fractions, you multiply straight across. So 1 times 2 is going to give me a 2. And then my denominator is going to work the same way. 2 times 1 is going to give me a 2. And 2/2 simply equals 1. So if I take this 2/3, let's go back to this. If I go to this 2/3, the reciprocal of that is going to be just this fraction flipped upside down. So that's going to be 3/2. If I multiply this fraction by 3/2, and I multiply this whole expression that I have on the right-hand side by 3/2, it's going to help me eliminate and solve for B. Remember, this 2 times the 3 here is going to give me 6, and 3 times 2 is going to give me 6 as well, which is simply just going to be 1B. 1B is greater than, and I'm going to write the fraction first, just because I think it looks nicer to have the number you're multiplying out in front, times the expression W minus G. Now, you don't really need a number in front of the variable. So this, if it's a 1, it's implied. So I'm just going to go ahead and box my answer here as B is greater than 3/2 the quantity of W minus G. This is your final example for today. Make sure that you have all of this in your notes. If you need to see a copy, remember they're always located in the bin, or ask your teacher for help today. While you are still in your group and while you're waiting for class to end, complete the rest of the problems in your packet. You have 8 additional problems in this packet today. I'm looking to see that you have tried all of them and you are eliminating and moving around whatever you need to move around to solve for the specific variable that's being asked. After you've done this, be sure to complete your exit ticket. You will turn this packet into the exit ticket drawer by the door when you leave class. I hope you guys are having a great day. Bye.